Hi everyone, I'm Joseph Poon. Today I'm going to be talking about plasma, its relationship with cryptoeconomics, trust, and also, a little bit about reasoning, perhaps some help with reasoning about the way the blockchain interacts with the local ecosystem here. This is all, the latter half will be more speculative when it comes to the way I interpret things, so I could be a little bit off, but it's something, it's sort of like my thoughts within this ecosystem. At first, I think I'm going to give a quick introduction of plasma and then go into sort of like reasoning about how it affects private enterprises and projects within certain types of structures. So if you're not familiar, plasma is a structure of nested blockchains, so blockchains on top of blockchains. It itself is not a blockchain, excuse me, but it commits state into an existing blockchain such as Ethereum. And it's currently built on top of Ethereum, and it's where all the fun research is happening. If you're curious and a developer, I would recommend checking out ETH Research. Just Google ETH Research, and you should find it and see where all the current research and development is occurring. It's a set of smart contracts, so it's not a consensus layer itself, but it builds a consensus layer on top of a consensus layer. And it works via fraud proofs, which is interactive processes around that. And you can do computation, and it's compatible with other on-chain scaling solutions. Example is like there's current research with regards to sharding and state channels and things like that. For example, you can build Lightning on top of this type of construction. So what it really isn't is it's not inherently a token. I'm not here to pitch some ICO or something like that. You can build tokens on top of Plasma, and there's some projects that do that. Notably, Omise Go, for example, is building on top of Plasma, and it's a protocol and open source software, and many of the projects building on top of taking leadership on that, and it's sort of a community project under that context. And I'm not here to pitch some enterprise blockchain solution for you, in terms of selling you something. I'm more here to sell you more on an idea and a way to reason about this space. Traditional enterprise companies haven't really been successful in this space. They haven't really produced any real value. If you talk to the enterprise blockchain people, they're probably going to be wasting your time. The only person I've been impressed with is Dan Robinson, who is, he started getting interested in Plasma. But there's a couple other exceptions, but by and large, the enterprise blockchain consulting companies are a waste of time. So design goals. So I think it's possible for one blockchain to encompass all encompass all worldwide computation. I think trust minimization is inceptually important, and it's basically what we're dealing with today. The prior talks when it comes to talk about trust, I think is very, very indicative of what the core researchers here are really talking about and thinking about. And payment and ledger scalability is incredibly important, as you see with the various blockchains receiving more and more load. Scalability is sort of like a hot topic these days because it's sort of the constraint factor for this stuff growing. If you want this stuff to reach 7 billion people, you damn well be able to process the transactions for that, and a lot of the people interested, whether it be technical or financial, that's where the importance is, and that's sort of what the design goals of my current area of research involves. Essentially, we're talking about blockchains on top of blockchains, and if you have a blockchain with some specific application, let's say you have a private blockchain, a decentralized exchange, some social network, or micropayments, you want to be able to commit some small piece of data into the blockchain, and if that data is wrong, be able to penalize people for that. And that's basically all it is, and it's there's a lot of engineering complexity around that, but that's basically the key insight is that you can reach scalability by committing small pieces of data on the blockchain, have stuff on a blockchain that runs on top of it, and then you basically resolve it that way. So you can have unique rules per Plasma blockchain. And we're talking about effectively decentralized applications at scale. And the periodic commitments are, very, very small, like hundreds of bytes, something which, I can read to you right now. It's that small. So there could be, great efficiencies representing perhaps even gigabytes of data or terabytes of data. And essentially, you just have these blocks, which get committed onto the root chain, and that's sort of how the construction is. If you've seen the prior Plasma talks, this should be, already familiar with all of you. I'm not going to go into detail with this. You can watch the videos elsewhere at your own time. Additionally, you don't need to watch all the data, and especially with the current research involving plasma cache, and plasma cache is plasma, right? So that's sort of like you only need to watch the relevant data for yourself. And so, if, for example, if gigabytes or terabytes of data are being transacted, you only need to watch the relevant parts for yourself. And you can ignore all the other tree aspects which don't. It's interesting because I think a lot of the current plasma cache constructions may be like this with splitting and joining of coins, and there may be some revisions when it comes to the paper and new co-authors perhaps even but we'll see how that works out. And it's developing into this like wider community. So why is this interesting, right? It's sort of like the way this construction works is sort of, if there's any type of fault or disagreement, you can basically go on a higher layer, right? So it's interesting because like this is effectively a court system, right? Like if you reason about the blockchain as a transactional system, it doesn't really make sense. If you view it as an adjudication system, like a court system, it makes much more sense. So there's like a local municipal court, and then there's like regional courts, appellate courts, and then eventually you get to the Supreme Court. And in this case, we're saying the Supreme Court is Ethereum, and it's a decentralized court system that adjudicates in a programmatic way. And that's how you really achieve that level of scalability. So it's only disputes that need to be adjudicated on the root chain, and like transactions in and out. So it's sort of like high value transactions in and out, and sort of like disputes. And then the periodic commitments that I talked about earlier. And that allows for high volume, low cost decentralized applications, and allows for a path forward when it comes to multiple strategies. Like I said, sharding is a very interesting research area. Plasma is compatible with that, and as well as state channels can run on top of that. So you can build this like stack is sort of the interesting aspect. If you're more curious about this, I think Vitalik talked about this recently when it comes to we'll talk about like sharding and stuff like that. So earlier what I was talking about was, you have commitments periodically on the root chain, and I presumed that, an authority would be creating these blocks. So you have a blockchain running on top of a blockchain, and maybe just, some guy, let's say like, some guy named, Alice is responsible for running everything. And, that's interesting, but it's not all that decentralized. How do you build this like decentralized network that nobody controls? And essentially, what Plasma's security mechanism depends on for full decentralization is some type of staking mechanism, right? So you can have the underlying blockchain be proof of work or proof of stake. Let's presume today it's proof of work. You can build a proof of stake system on top of a proof of work system, and essentially the tokens are effectively a security mechanism to ensure that the blocks are being created correctly, right, on various levels, and that's fairly relevant for a lot of the people interested in the token space right now, because it's an alternative model for the economic incentives around tokens. Right now, a lot of the tokens are very like, oh, we're building this transactional system, and a lot of them don't really make sense, right? There's that meme that's like, why don't you just use ETH, right? And I think that meme is totally true. For something like this, I think it's totally different, whereby you're holding the token, you're acting as an individual operator within this, and you create a block. Let's say by owning a token, you have a proportional right to create a block. And by having a proportional right to create a block, let's say you own 0.1% of the tokens, you have the right to create 0.1% of the blocks. And when you do that, you can collect the transaction fees and thereby receive funds from that. What's interesting is that each individual actor receives different returns based on their individual activity. If you act maliciously using the tokens that you own, then or faulty in some way, you can have dramatically lower returns or even negative returns relative to other people. This gives you, a second layer proof of stake, and it essentially what this does is creates cryptoeconomic incentives against halting and various other Byzantine activity, which you couldn't do without this token being bonded. So that's sort of like a new way to reason about potential future token models and token economic incentives, and it's the core security mechanism beyond the smart contract. So there's sort of two components. There's the cryptoeconomic incentives of the tokens, as well as the effective assurance committed to via the smart contract before this child blockchain is created. And by the way, a lot of this research is happening, like I said, on ETH Research. There's a lot of projects which claim they can do a lot of scalability. Be very, very critical of that. The amount of BS in this space is very, very high. A lot of people that do, a lot of the constructions involving, proof of stake simply don't work, and that's why it's taking a long time. The worst of it is projects like IOTA, which straight up are hostile to researchers. IOTA is probably one of the worst projects I've seen when it comes to engineering robustness, when it comes to research. I mean, insulting MIT researchers is probably the worst thing I've ever seen. And it's especially interesting because a lot of the people that do DAG constructions, DAG, DAG constructions without bonding and without proof of work basically don't work. Those things, if that was possible, the blockchain would have been invented. Cryptocurrencies would have been invented 20 years ago if that was possible, right? They'd be very, very skeptical of a lot of these constructions. A lot of people claim that they can do, blockchains on top of blockchains, but, this is a very, very new emerging area of research, and, will take a little bit of time to fully flesh out. We're going to switch gears now, and we're going to be talking about why is this relevant, right? Like, beyond the issue of scalability, why is this interesting? What I find compelling about this is that you can build private blockchains on top of public networks, right? And that's very relevant because a lot of corporations, especially large enterprises, are interested about this topic. You can reason about this in a similar way that intranets connect to the internet. Right? What that means is that you can run this private system that you're sort of setting the rules and the terms and the contractual agreements beforehand. But by building on top of a public network, that allows for you to have the full benefits of a privately controlled network, but public enforcement. Right? That allows for enforceability on the public system. Right now, a lot of the proposals for private chains presume private coordination. And the issue with that is that if there's any type of fault or disagreement, where do you go? Right? If there's 5 parties agreeing on some transaction, if there's a fault, let's say they all disagree on what the current state is, where do you go? Well, eventually they're probably going to sue each other and go to court. The alternative is there's a level of determinism that you can build on top of a public system, and that allows you to construct a system whereby you know deterministically where the program is going to result in, and that allows for greater efficiencies and lower information costs. So Ethereum really lets you have your cake and eat it too, in that you can build a private system on top of a public system. So my theory is that private chains without public security is very problematic. Because without public security, it requires coordination and legal costs, which have close to no efficiencies compared to existing business processes. I think basically, if you're not backed by a public system, you're creating marginal back office improvements and probably not worth the switching costs. There are exceptions to this, but that in a general sense, I think that's just largely true, and this is a personal opinion of mine. I think that business processes can be significantly cheaper and more efficient with public networks, since the commitments to smart contracts are actually cryptoeconomically enforceable, and that creates assurance and commitments for business processes. By that I mean that you basically have assurance that some other guy can't even go to court. Like, this is basically arbitration times 1,000, right? What we're talking about here. This allows you to come to an agreement between multiple parties privately, and if you ever disagree, you can go to the public system and programmatically process it, right? Like, that allows you to obviate around environments where there's corrupt courts, which is why, you know, third world and Africa can probably benefit from the blockchain. It's not like payments, right? Like, and I think you know, the talk about payments in Africa was fairly interesting, but I think the biggest impact probably is about the need to obviate things into a decentralized arbitration system. And you know, it's interesting because the theory of the firm is not really being talked about with this. I think it's very, very important to reason about when you need private systems and when you need to put something on the blockchain. Is that, you know, why do corporations inherently exist, right? This is MBA 101. Right? In the first semester, you learn about this, just like in the first semester computer science. You learn about the big O notation, right? And asymptotic like complexity theory and stuff like that. So why do corporations get large? Why don't I just individually operate as an individual actor? Why are there corporations with tens of thousands of people? Right? Businesses grow fundamentally, and this is the theory of the firm, when it's easier to trust internal organization over external consultants, right? There's this boundary, right, between inside the firm and outside the firm. And when you operate within this boundary, there's a trust agreement, right? You all agree that, like, hey, we're part of this corporation, we all generally trust each other and have the same ends, and then transaction and information costs drop dramatically. Right? That's why corporations grow large. Why not just have someone else outside do your work for you? Right? Why not just pay them? It's so much easier, right? But you do it fundamentally due to trust problems. You don't trust outside actors. There's a lot of underwriting costs, transaction costs, et cetera, as a consequence. The combinations of blockchain and tokenization allow for breaking down this theory of the firm or recontextualizing it, which severely reduces the cost of coordination with external parties, which therefore reduces the need for an internal organization structure. Basically, the notion of a corporation or conglomerate is being directly can directly be changed in a very, very significant way as a consequence of the blockchain. And when you reason about internal business processes, inter-organizational business processes, this is the interesting aspect of enterprise blockchain projects. And with projects like Plasma, one can have a private network of participants with high performance without releasing all the business data and logic to public networks. And this is where I think the key is going to be when it comes to large conglomerates. I think that it's possible for projects like Plasma, combined with tokens, to be the largest threat to chaebols. Like, we're talking about, you know, SK, LG, et cetera, et cetera, et cetera. And, like, I think this is fundamental, right? You know, like, why do conglomerates exist, right? This is global, right? It's not Korea just that has chaebols, right? Chaebols, right? Keiretsus, right? We're talking Mitsubishi, Mitsui, Mr. Lee's Greater Hong Kong, basically Li Ka-shing, Hutchinson, et al. Berkshire Hathaway with, you know, Warren Buffett. Conglomerates are global, and, you know, oh, shoot, hold on. What happened to this? Okay, there we go. I don't know what's going on with this, but, like, it seems to be just, like, backtracking for me. Well, thank you. I hope you enjoyed the presentation. I only have a couple slides left. So conglomerates are a fascinating topic, right? Like, I think this is the area of fundamental research that if you work in one of these conglomerates, that you should be focusing on. Because this is not about like a direct frontal threat. It's that, like, the world is changing, right? Look at the internet, right? How do you do this shift? Korea had this basically positioned itself excellently with the introduction of mobile telephony, right? And that's where we're getting at here, is that we're talking about a fundamental shift of not a technology only. We're talking about a fundamental shift in business processes on the deepest level, right? We're talking about the conglomerate trust broker, right? Conglomerates, they're often centered around a strong financial core, often operating through a commercial bank or interlocking ownership. Within Korea, it's the notion of interlocking ownership because they're largely prevented from doing that. With associated businesses for revenue generation. And in particular in Korea, that's why you see, the conglomerate basically, like in this case, they have interlocking ownership. In other jurisdictions, the relationship is that the conglomerate banks its affiliates entities, and you have basically an operating bank within that context. And this type of context is much, much more effective because, like, for example, in places like Japan, this banking system can basically trust its affiliated entities, right? If you're part of Mitsubishi, you can trust the other entities within Mitsubishi, like let's say Toyota, to basically operate correctly, right? They're just like, okay, we're all friends here, we're all in the circle, we can basically have a presumed level of trust. If you break down the need for trust, which is what the blockchain does and which is what prior presentations talked about, you basically replace the need for a lot of these conglomerate structures. Right? And there's a presumption of like, well, why are there so many conglomerates in Asia, right? Is this a notion of Asian values, right? Quote unquote Asian values? Or is it a reaction to norms around jurisprudence or some legal structure? Now, I don't have the right answer for this, but my working theory is that, within Asian cultures, the legal system operates a little bit differently. And as a consequence, there's lower presumptions of enforceability, and there's a stronger need for this type of corporate structure. If you remove this need for this type of trust, if you have a separate adjudication layer, then basically the conglomerates change dramatically. And I'm thinking that's maybe what ends up happening, right? And that's why, this is a global force, and this is something absolutely to pay attention to. The blockchain space has basically a fundamental transformative change within that context. Let's talk about like Korea, right? Like, I'm not an expert in Korea, but my observation is, familial relationships are very strong as a consequence of basically the inability to create these types of, basically holding banks. And as a consequence, you have these interlocking ownership relationships. So there's some basically policy reasons for the result of these types of structures. I think the blockchain fundamentally disrupts these types of corporate structures worldwide. You have public networks that have the ability to enforce multi-party semi-private chains, and this is a direct replacement for much of the financing currently brokered by these types of conglomerates. If a business process can be placed on the blockchain via an Ethereum smart contract, it can severely reduce the transaction costs due to the assurance around trust and other information costs, right? And that navigates certain types of, and you sort of need to navigate this disruption. Is sort of what I'm presenting today. Like, one can either fight it, or one can build up a team of expertise and reason about its effects, right? And that's what a lot of people that did that transition with the internet, with Uber and ride sharing, with mobile telephony, right? Like, the telecoms were probably the star example of entities that were able to successfully pivot. And this can bring about that means that large conglomerates may be able to pivot successfully into this global, global narrative and this global push into a change in terms of business processes. The telephony, the telecoms were able to switch to mobile very, very, very successfully. And in the future, I think what we're thinking about in the future, and my current area of research, is not just scalability, but I'm going to have a paper coming out soon around research involving using the blockchain to achieve mass coordination of goals and essentially coordination mechanisms, and combined with interblock, and then I think that's going to be a big factor. My current area of research with, and you can look this up on ETH Research with other parties doing a lot of interesting stuff with Plasma, can enable a great deal of not only scalability but coordination on the enterprise space. And I think this may result in the disruption of not only industries but the business process of the conglomerate itself. And that's sort of why I think people that talk about enterprise blockchains are not reasoning about this space properly. Like, it's not about, selling your customers tokens and putting them on your platform like airline miles. It's fundamentally disrupting your own business processes and the business processes with your suppliers and things like that. And people talking about things like supply chain management may not be able to reason about it correctly, because it's not about, the supply chain flows. It's about the trust relationships between entities. And conglomerates are sort of one of the biggest opportunities for this space to change and dramatically shift. So that's sort of my presentation. Thank you so much.